All right, so hello everyone. Let's start with the next session. My name is Robert, and I'll be talking about continuous integration and how we do continuous integration for backend projects and how you can possibly use them in your own projects. So let's start, and let's address the first major question that you could probably have about continuous integration, that's what continuous integration actually is. Continuous integration helps us identify, oh, sorry, did I skip something? No, good. So continuous integration actually helps us understand some key questions about software development. And the key questions are like, does my software still work after I've made my changes? Can I actually deploy this piece of software? Can I install all the components of the software that are required to work? And the continuous integration actually helps us achieve and answer these questions by constantly checking if our code works by actually running the code. And probably you all write unit tests, right? Do you? Come on, raise your hands who writes unit tests. Great. Okay. So yeah, that's the key point in the using continuous integration, because if you don't have any unit tests, then there is nothing that the continuous integration can run to actually check if the code still works. So that's the main part of successful using continuous integration. The other thing that can possibly help you with continuous integration and ensuring that the components still work is to make sure that you have all the dependencies of your project somewhere declared. So for example, if you use NPM, it happens to me a lot of time that I just try some module that I found on the NPM registry. I just install it with npm install, but I don't save it in my package.json. And this can actually, using continuous integration can help you ensure that you didn't forget to save that dependency. So that next time you actually run the code, it should be installed when you install the software. All right, so how it actually works and what's the process behind continuous integration and running the jobs. So the first point is that usually continuous integration is integrated with Git repositories. So for example, GitHub or Bitbucket, or maybe some repository that you have hosted on your own network. And it works by receiving some kind of notification from this repository, because usually you want to start the job when you push new code. And Git usually knows best when that happens, because you just push it. So it receives some kind of notification. It starts some kind of isolated environment. It could be a virtual machine, it could be Docker container, it could be anything. And really the key point here is that it needs to be isolated from each other, so that one job cannot influence the results of the other job later or sooner, or parallel jobs. It has to be really isolated. And this is important because, for example, if you do testing on your local computer, then obviously each change you make to that project, even if you run your unit tests, you can't guarantee that what you did 5 minutes ago does not influence the results of that test, because the state is still on the computer. So whatever you install, it's in your hard drive. And if you run an isolated job for this task, you should always start with a known set or a known state of the machine. So for example, you get a fresh virtual machine, like fresh system, and then you need to install everything from scratch that you just did in the last, 5 minutes. So really the key point here is that it needs to be isolated. And then obviously it needs to obtain the code somehow, so it usually clones the project and runs some tasks that you have to define explicitly in some kind of configuration file. Some services provide defaults. So for example, there is a service that if you tell it that, yes, my project is NPM, or Node, then it will assume that your tests are to be run by running npm test, and your dependencies need to be installed with npm install. But these are defaults. Usually it's best to actually specify them if you want to override it, or if you want to really make sure that this is what's happening. And then obviously the most important thing is that it should tell you if something breaks, right? So if you messed up, like you forgot to add a dependency to your package.json, it should tell you it should send you some kind of notification. And since it's just running tasks that you can configure, you can ask it to do anything, really. So if you can script it, if you can write a script for that, you can make it part of your repository, and you can have continuous integration do it for you. All right, so let's talk about what you can use continuous integration for in a real world. So obviously, the first thing coming to my mind is that you need to, or you want to do, run your unit tests so that you make sure every time you commit something, you push something, then the unit tests verify that what you just committed really are tested. Another important thing that at least we do is to run some kind of static code analysis on the code. So who's using, for example, ESLint, JSLint, JSLint? Right, some of you, good. It's really important because, for example, in JavaScript, if you don't use these tools, and it might happen that you forget to write your unit tests for that particular code, you might use, for example, a variable that you didn't declare before. So that's a runtime error, right? So you can't just like make up your variable in some kind of statement. So static code checks actually allow you to catch these early errors in the code. They kind of help you do what normally compilers do for you, right? So if you start compiling a C application and you use a variable that you didn't declare, you get a compile error. So static code checks kind of try to help you in this area. So it's good to run those as well. And another important thing is that since you write tests, you actually sometimes might need to know which parts of code you actually test, right? So you don't want to have like 10,000 lines of code, and then you have 2 tests, and then you discover that, okay, so those 2 tests only test like 10 lines of code, right? So you might have some tests, but it doesn't verify anything. So some kind of code coverage reports that actually tell you like, okay, so you have this part tested, but the rest is like untouched. So that's great to do in a continuous integration as well. The other thing is you can use it to generate documentation from your code. So if you use the doc blocks in your code that you tag, like what parameters my function accepts, you can have it to generate the documentation, maybe even publish it somewhere so that colleagues or your consumers over API have always the up-to-date version of the documentation. And we also use it for release management. So imagine that you're writing or using an API. It's usually good practice to not depend on release management yourself. Like you don't want to go into Heroku and just like, yes, now release. So you want to do it, for example, if you push to develop, it will release for you. If the tests pass, you can have it released automatically to Heroku to some kind of like pre-production version, and have your colleagues that work on other platforms maybe to test your API right away on that version. And you can also probably configure it that if a commit is tagged, like you tag it with a version number, you can maybe have it released to the production right away. So it can all be configured for you, and then basically your whole workflow stays in Git. So you just like commit and push, and you don't care about anything anymore. There are 3 major providers, at least that I know of. I'm sure there's more, but these are the 3 most important ones. The first one is Jenkins. It's great if you really need full control over the whole testing environment, because you can actually download it, install it on your own hardware or own servers that you have. You can customize it, you can really do crazy things with it. So that's great. And also it's great if you, for example, run some project that you just can't host on GitHub, or you just can't push the code somewhere else because of some contract obligations. So you can use that as well to actually run continuous integration without leaking sensitive information, for example. Then there is AppFair. It's great for Windows. It has awesome Windows integration. I think Windows is actually the only thing that it supports, but it's great. But it's hosted, so it's a third-party service that you need to configure, and you can't just download AppFair to your own server and start using it. And then there is Travis. The disadvantage of Travis is that it only works with GitHub. So if you, for example, have code on Bitbucket, you're basically out of luck with Travis. So you have to use one of those 2 other options. Or maybe the Atlassian actually has their own product. I'm not sure how it's called. Bamboo, right, thank you. Great. So you can use that one probably. And Travis is awesome for anything that works on Unix platforms. So Linux or macOS or whatever projects of this kind, you can run on Travis. All right. So since we use Travis for Node.js testing on backend, then the rest of the presentation will be specific to Travis. and we'll talk about some examples and show you actually how it works in real time. So there are two options how we can use Travis. If you have an open source project, then you can use the Travis CI org domain, and if you have private projects, then you have to have a paid plan, and you can use the travisci.com domain. It provides you with a Ubuntu 12 version runtime, so every time you run a job, the environment in which it's going to be run is based on Ubuntu. And the way you configure it is you create a travis.yml file in your project root, and every time you start the job, then Travis will actually have a look at the file and read the configuration from it and run the tasks that you define here. I will show you how it looks like later. And basically the only thing that you need to do to have your project use continuous integration in Travis is just like really enable it on the Travis environment, in the Travis configuration. And then every time you just git push, and it will receive the notification from GitHub, and it will start the job, and it's awesome. All right, so you have two options how the environment actually looks. So it's always Ubuntu 12, but you have two options. You can either use a full virtual machine, or you can use something called Docker. Who knows Docker? Great, that's perfect. Who tried it for something? Right, okay, good. Well, Docker is awesome because it kind of looks like virtual machine, but it's like nothing compared to virtual machines. And the benefit of using Docker is that it's fast. It doesn't need to boot the whole system. It just needs to, it's basically a container, and you start doing commands in it, and it looks like it's working. It's magic for me. So you have two options for Travis, how you can use it. So either you use the full virtual machine on Travis. If you use the full virtual machine, then there is a slight delay before Travis actually starts the job, because it needs to really like start the whole machine. So that can take like a minute. And if you use Docker, they claim it's usually like 1 to 5 seconds before the task actually starts running. So it's extremely fast. However, there are some drawbacks, or there are some trade-offs that you have to make. So if you use the full virtual machine, you can do anything with the machine. So you can install packages, you can modify configuration files, whatever you can imagine, except rebooting probably. But with Docker, there is one serious limitation, and that is that you can't use sudo commands. So anything that requires root access, you can't do it. Usually, at least from my perspective, for Node.js projects, I don't need sudo, so usually I just use Docker because it's fast. And actually, Travis provides various add-ons, so to speak, that can help you kind of like work around the limitation of not having sudo. For example, by giving you an add-on that install apt packages for you, or modifies some other system files. So you can use that once. I will show you also as well a little bit later. And there are several lifecycle events, so to speak, that you can configure, and how that you can use to modify the behavior, or ask Travis to do the stuff that you need to do in order to verify that your application actually works. So the first two, they deal with making sure that your application has everything you need to actually verify that it works. So for example, the install lifecycle, usually it runs npm install, right? So it installs all the packages that you need in order to make sure that the test actually can be run. And in here you can also use, for example, if you use the full virtual machine, you would put here, for example, apt-get install and some package, if your application actually depends on them. Then there's the next two, the before script and script. These deal with running the commands that needs to be run in order to ensure that the application works. So for example, this is the npm test maybe, or basically running your test suite, running all linters, running any command that verifies that your application works. Then you have two options to alter what should happen if the tests fail or they pass. So you can have some custom actions if the default ones do not suit you. And then the next three, they deal with deployment. So this is what I mentioned, like you can have it configured to deploy automatically to Heroku, for example, on release it to NPM. So you can alter how it should behave in these scenarios. The deploy scripts usually only work if the tests pass, if anything works, because obviously you don't want to deploy anything that's broken. And then the final one, the after script, is done after everything is done. So you can have maybe some custom actions done, maybe post a notification by email or to Slack, whatever you want. All right, and now let's have a look at how it actually looks in a real project. So I'll open a project of mine. Great. All right. So this is a project. Let's not go about too details like what it actually is, but it doesn't matter. So there is a Travis IML file in the root of my project, and it looks like this. It's a YAML syntax. I don't know if you guys actually are familiar with this, but it's pretty straightforward, and Travis has great documentation about it, so we don't need to care about it too much. So this line actually makes sure that I use Docker, because I'm declaring that I don't care about sudo. I'm setting the language to be Node.js, which provides some defaults, like it will run npm install for me. I don't need to declare it myself. And here you can specify what versions of Node.js you want to test against. And you can have multiple values here. For example, you want to make sure that your application works on Node.js 4 and Node.js 5.10. But since this is a backend project, it's not for third parties to use, then I have full control over what environment it runs, so I only have one. But if you want to make sure that it works on, for example, some legacy versions, because your customers might need backwards compatibility, you can put any number of versions here, for example, 10, 12, maybe 4.0. And for every version that you declare, Travis will spawn a separate build, so that every time it runs, it will make sure that the build actually works against that version of Node.js. And this script part, this is what I define that I need to run in order to make sure that my application works. So this make lint command, this will start ESLint, and it will make sure that my files are okay. There's no syntax errors, for example. And there's other checks. And then there's a make test, and this runs my test suite. So it runs all the tests that I wrote, and it verifies that they work. And if any of these commands return a non-zero status, this is the default behavior. I'm not sure if it also works that way on Windows, but at least on Unix systems, if you return non-zero status, it means that something failed. There was an error. And if you return 0, it means like, yep, this was successful. So Travis actually monitors the results of these commands, and if they return non-zero, then the build is considered to be failed. You can also define some environment variables that may influence the behavior of your application. So for example, I'm quite sure you have already seen the pattern that some people define node env variable when doing, for example, backend projects. And they might somehow influence the behavior of some packages and of some libraries. So this will be available to you. For example, if you declare node env like this way, then if you have a node process, then you can access that variable like this. It's undefined right now, but yeah, on Travis it will be defined to whatever variable you set here. Now the next section deals with the add-ons. So if you remember, I mentioned that Docker does not allow you to fully control the environment. So because you don't have sudo, so you can't just do whatever you want. So add-ons provide somehow a mechanism to install packages maybe, or do some custom configurations that your application depends on. So for example, in here I have an apt add-on that installs additional sources. So I'm installing GCC and G++ because I just need them. Another option you can configure is to cache something. So you can have, for example, node modules cached because maybe your application uses a lot of modules and it takes a lot of time to install them. You can optionally have it cached. So by the end of the build, Node.js will pack all the node modules folder. It will upload it to some remote storage option server. And on consecutive builds, it will first look if the cache is there. It will try to download the cache and then use that instead of just plain installing it from scratch. And actually, npm is quite smart that if you do, you can for example do npm prune that will get rid of anything that is not defined in package.json but is present in the node module, so it will just remove it. And then over that, if you run npm install, it will also install anything that's missing. So you always have, you can be sure that there is like no state preserved between the builds. So this is great. And also if you change the runtime, so for example, right now, if I have a cache and I'm building with Node.js 5.10, if I modified this to be 6.0, which is soon to be released, hopefully, then the cache will be invalidated because the runtime changed. So you don't have to worry about that one. And here, this is the part where you can configure the deploy script, for example. So we are deploying to Heroku. This application is deployed to Heroku. So Travis has some pre-configured options or pre-configured deployment scripts that you can use. One of them is Heroku. And you can tell it that if you push to develop, it should deploy to this application, to this Heroku application. If you push to master, you can deploy to another application, for example, and so on. And another important thing that I want to touch, that you can use, for example, secret variables or passwords inside this file. And the way it works, that you can see that this is some secure variable, right? So this is the API key, and it's called like secure, and there is some long value here. And the way it works is that Travis has a private key that you have no access to. And if you, for example, use their command line utility, they provide a Travis command, so you can install it via gem. There is a command called Travis encrypt, and the way it works, that you can specify an environment variable here to which you want to put that value. So, for example, I would say my secret. I can put a value here. Something like that. Maybe put it in like this, and you can ask the command to actually add it to your Travis INL file. So it will first detect that, okay, I'm seeing that you are in a repository called something soundtrack. It will check if that repository is enabled on Travis first, and internally they will do some sorcery as well, and they will encrypt the value with that private key that only Travis knows. And so if I add this here, you can see that there was something added to my environment option. So there is a global, and there is a secure, and it's basically the encrypted value. So you can't see it in plain text in here. So this is great if you have, for example, open source project that no one can actually see that value, because that would be stupid. You don't want to give people your API keys to deploy your application. So this way you can protect sensitive information, but still have the continuous integration server to do something that only you, for example, could theoretically do. So it's great. All right, and let's have a look at how it actually looks like when you run a job directly on Travis. So if I go to Travis CI, you can see that there are some projects here, and this is the soundtrack project that I was just showing you the configuration from. And basically, this is the output that Travis gives you from running your tasks that you define. So you can see that it uses Docker containers. There is some build system information you can inspect. You can have a look at what it actually uses by default. You can always override it somehow. So that's great. It clones your repository. You can see it's cloning somewhere. Then here it is exporting the environment variables that you define in your file. If this was a secret variable that was defined with the encrypt command, you would not see it here, that there will be only just asterisks here, so you can't just read it. You can see that it's installing the version of Node.js that I specified, and then there is the build cache. So yeah, it tried to fetch the cache, it found it, and it's unpacking it into my Node modules. And then it's basically installing my script. You can see that there was some minor change here done. So it doesn't install everything because there was the cache. And at the end of the build, you will see that it uploads the cache again because it detects changes. So it always keeps it up to date. And now you can see here that it runs my make-lint command that I defined in my Travis, and then make test. And of course, you can see here that make-lint exited with 0, so that was probably success. Now there's the test suite, quite a lot of tests, I'll just skip them, that's boring. And at the end here it uploads the cache again, so you can see that there was some changes detected. So it rebuilds the cache. And here it's doing the deployment. Have you guys actually tried deploying anything to Heroku? Who tried it? Right, great. So you might recognize this log. This is the default build log from Heroku. So the deployment script actually what it does is just it packages the application that you just tested, it sends it to Heroku and asks it to like, hey, this is the new version, just deploy it, do something with it. And then the following logs are directly from Heroku. So Travis is like kind of out of the game for now, and it waits for Heroku to build the application and deploy it. And once that's done, it should tell me at the end that everything is done. My build exited with 0, which means that it's green, it's passing. And since we are actually looking at this, I can just try to restart the build and just have some fun with it. See how long actually it takes. Right, so it took like 3 seconds, maybe 4 seconds to start the build. If this was a full virtual machine, it would take probably like a minute or something. And now we can just keep watching and marvel at its genius. It's great. Right. All right, that's it from me. Do you have any questions about continuous integration or anything about deployments and stuff?
Just one simple question. Is there a decrypt function? Because you encrypt it, so you can decrypt it back?
Oh, actually, Travis does that for you. So by the time your build runs, the values are actually already decrypted. You just can't display them on the logs. So if
I mean in the config file.
Oh, in the config file? Oh, I'm not sure. I'm really not sure. I never tried it. I always just like encrypted stuff.
Yeah, I mean just for recovering password.
Yeah.
Recovering those secrets.
Yeah. Well, my paranoia tells me that I don't want to have this functionality, you know, because if you want to put secret stuff in that, you only want to have it make sure that it works only one way. That even though maybe somehow you gain access to the Travis file, you don't want people to just like maybe try something how to decrypt it. It's definitely possible because it's like symmetric encryption. So if you have the private key, you can definitely decrypt it. But to my understanding, only Travis has the private key, so you probably can't decrypt it.
When you call encrypt, it calls Travis, it encrypted it. So when you call decrypt,
we can have a look if there is a command actually for decrypt. I never tried it seriously, so let's see if I put Travis decrypt. I don't know. Yeah, that's unknown command, and Travis encrypt. Maybe there is a help option here. I don't know. The book. Nope, it's not here. Yeah. All right. Let's watch the logs maybe for more. All right. Now it's deploying already. It's very fast. Great. Okay. Any more questions? All right. If there are no questions, then definitely I will be around later. So if something pops up in your mind, just grab me and ask. Okay. Thank you very much.